Hi, so let's continue with our Journal Holiday Week 3 assignment. Let's go through the assignment. Okay, question 1. So this is basically the concept of weight and mass. So if you recall, weight and mass, or rather weight versus mass, weight changes on different planet. Due to different G. Whereas mass do not change regardless on any planet. So the formula here is W weight equal to mg. So let's figure out. So it says that it's 15 kg. This is the mass. So you see mass is 15 kg. Mass do not change. Means mass is 15 kg. Straight away eliminate C and D. Next one, weight. So let's calculate. So W on Earth equal mg on Earth. So throw in a number. M would be equivalent. We have m. So in this case, what do we have? Okay, actually we have the weight, the mass. So your W on moon equal to m g on moon. M is 15 kg times g 1.6 equal to 24 Newton. So answer is A. Okay, next question. So the measuring cylinder has a mass of 120 grams when empty. When you add in 50 cm³ of liquid, the mass becomes 160. So that tells you that the mass of your liquid is 40 grams. If you recall, density equal to mass over volume, which is 40 gram divided by 50 cm³ equal to 0.80 gram per cm³. 2SF. So answer is A. Okay, question 3. Question 3 looks a bit interesting, but you just have to read the context. The keyword here is the same pressure is applied throughout the same liquid. Means that whatever pressure downwards here is equal to the pressure upwards. So let's remember the formula. P equal to F over A. So what do we know the segment of piston Y. So the pressure at Y, which is equal to force, which is 80 Newton over 40 cm². This is equivalent to the pressure at X. Why is that so? It's highlighted in orange. The same pressure is applied throughout the liquid, which in this case 80 divided by 40 is actually just 2 Pascal. It's just 2. So Px equal to force X over area. We are trying to find the force. So Px and A. So it's 2 times 2 equal to 4 Newton. B. Alright, next. You have a bicycle. Cool. So read, it says it accelerates until a constant speed is reached. How the size of the air resistance change when it is accelerating. So if you recall, we don't have to know the formula in this case. What we do need to know that when speed increase, your air resistance increase. That's what we need to know, but there's no formula per se. So in this case, you just have to say that it increases. That's all. Because when it's accelerating, your speed is increasing. So when you're accelerating, it means you're getting faster, isn't it? So now you're supposed to compare very simple. Read constant speed. Constant speed means there is no acceleration. If there's no acceleration, that means the resultant force, there is no resultant force. The resultant force is 0. But what you know here is there is a driving force and there's air resistance. So you say that the two forces, the magnitude are the same. So that they can cancel out because they are on opposite direction. Okay, next. Calculate the energy in the kinetic store. The energy in the kinetic store is actually the formula half mv squared, which is half times 75 kg times 4.0. 0.5 times 75 times 4. 150 meter per sec. 150 joule. Cool. Oh yeah, that's it. Okay, next one. Label the forces. So there are quite a few forces here. And technically, there are 5 forces here that we can label. Yep. So most of them are contact forces. If you recall, Newton's third law stated that there is always an action-reaction pair. Yep. Okay, question 2. Pressure. If you recall, P equal to F over A. So P is 6500 divided by 100 equal to 65 Newton per cm square. Oh, cool. That's it. Why would we want to make it more pointed? That means instead of this, it becomes this, more pointed. Because by doing so, you're actually causing the area to be smaller. Remember, P equal to F over A? If your A is lower, the same force, but you have a smaller area because it's pointed. This results in higher pressure. That means it's easier to push the post into the ground. It's like you drink bubble tea, you drink Koi, you definitely use the straw with the pointed edge and poke it into the drink. You don't do the opposite that side. Same idea. So that's physics in real life. Okay, next, question 3. Graph. Cool. So, if you recall, the gradient of a graph is always y-axis divided by the x-axis, which in this case, speed divided by time is acceleration. Cool. So that is acceleration. And the area under the curve, the graph, the curve, is the y-axis multiplied by the x-axis, which in this case, speed times time equal to distance. Question is asking for distance. Cool. And read carefully first 20 seconds. So you're literally finding the area of a rectangle. That's pretty easy. $25 times 20 equal to 500 meter. Cool. Yep. Okay, next. Oh, during braking, which is the last 5 seconds. Braking. Braking means what? You are decelerating. Means you're slowing down. Braking. Oh, it's 24. Oops, it's the 4 seconds. So this is 20 seconds. This is 4 seconds. Read carefully. Okay, so you have to calculate the acceleration, deceleration. Do you recall there's a formula? There is a formula, which is A equal to V minus U over T. Okay, perhaps you all don't like that. V final minus V initial equal to T equal to final is 0. Initial will be 25 over T. It's 4 seconds. 25 divided you get minus 6.25 meter per second square. So you have a negative acceleration. So don't be tricked. Deceleration. So your acceleration is negative, which means your deceleration, can you remove that sign? 6.3 meter per second square to SF. Cool. Next one, braking force. Oh wow, what's this braking force? Okay, let's take a look. Oh, you have acceleration. F equal to MA. Equal to, what's the mass? Mass is 800 kg times 6.25 times 800, you get 5,000 Newton. Cool. Yay. Okay, the next part is FYI, meaning for information. We will learn that soon. So this is about power. So you can, of course, listen and try to have a glimpse of what you're going to learn soon. So power is essentially how much energy is transferred per unit time. So what happens here is, initially, your speed is higher, isn't it? 25 meter per second. And you recall, your energy in kinetic store is half mv squared. That means this is also higher. So there is more energy transferred per unit time, which is actually just power higher, power greater. Okay, next one. Center of gravity is a pretty standard definition, along with velocity, along with principle of conservation of energy, principle of moments. These are some standard things that I have to ask. So, center of gravity definition is a point on the object where the entire weight of the object appear to act on. So what happens? You remove the force F. So what happens is the object will tilt left and move in a anti-clockwise movement. Why is that so? Because of the weight. Your weight is on the left hand side. It's essentially the left hand side of the pivot. Essentially. So it results in a anti-clockwise movement. So yes, you tilt and move until the base touches the, I guess, a table or the surface, that thing, like this thing. You eventually end up as this. Oops. Again, next one, principal moments is another definition. So principal moments simply states that when an object is in equilibrium, the sum of clockwise moment is equivalent to the sum of anti-clockwise moment about the same point, about that particular point. Okay, label the center of gravity. So you need to read the question. Question says what? Uniform beam. Uniform beams means it's in the middle. And read, the beam is pivoted in the center. They all mean the same thing. It means where is your weight? The weight of the beam, which is basically Q, the center of gravity, because that's where it's supposed to act on. Oh, would it produce any moment? If you recall, m moment equal to force times perpendicular distance. In this case, the perpendicular distance is 0. So it will have a moment of 0. So no. Next one. So there are only two forces technically you see here. So the one, your load. Oops. The one in purple. And the one in orange. The weight, it doesn't produce a moment. I'm ignoring it. So your anti-clockwise moment equal to clockwise moment. So this is 1.5 times x equal to clockwise 2.5 times 18. X is equivalent to 2.5 times 18 divided by 1.5. 30 cm. Cool. Yay. And lastly, what happened? Now your pivot, give it a different color. Maybe I give it a light blue, green. No, but blue, light blue. Shifted to the edge of the table means your pivot is now like this. So what happens is it will move this way. So your beam will become lopsided, basically, like something like that. So what can you do? You can do two possible things. They only say one, but you can do two. Either you move your 2.5 Newton load to the right, closer to pivot. Or you move your 1.5 load to the right, further away from the pivot. Yep, that's about it. Thank you. And if any questions, please ask me on WhatsApp. Don't hesitate at all.